Alrighty, Unit 11, and we're going to talk about graphing exponential functions and logarithms and logarithmic functions. Alright, the first thing we're talking about is graphing exponential functions. The parent function for any exponential equation is always y equals b to the power of x, where these 3 points, -1 and 1 over b, 0, 1, and 1b are always on them. Also remember that a transformation equation has the format a times b to the power of x minus h plus k. A controls whether it is flipped across the x-axis if it's less than 1. Also, it determines if it shrinks or stretches vertically. B will control growth or decay, kind of like the rate of change. H controls horizontal shifts. K controls vertical shifts. And then remember that there will be a horizontal asymptote on exponential functions. The parent function has a horizontal asymptote of x equals 0. I said it right the first time. Y equals 0. However, the new transformed graph will change depending on if there's a value of k or not. So let's graph this function. We're going to graph both the parent and this one. And then we're going to determine if it has growth or decay and state the domain and the range. So the basic function is y equals 5 to the power of x. 5 being the base, that's b. And then, again, all that extra stuff is part of the transformation. So the original coordinates are going to be -1 and 1 over 5, 0 and 1, and 1 and 5. So we can graph the original function. Here's 0, 1, approximately 1, 5, 2, 3, 4, 5 is up there, and -1 and 1/5 is less than half, but just put in your best guess. And it will look kind of like a J. But remember, it has a horizontal asymptote at the x-axis. So it's not allowed to touch it or cross it. So we'll extend it to remember that it doesn't. Alright, so now we're going to take each point, and first we're going to multiply the y values by half, because according to order of operations, multiplication comes first. So I'm going to multiply my y values by a half, which means 1/5 becomes 1/10. I said tenths and I wrote 12. 1 becomes 1/2. And then 5 becomes 5/2. I then am going to take these values and add 1 to them. So 1 over 10 plus 1 is 11 over 10. 1/2 plus 1 is, my pen is not cooperating right now, guys, sorry, 3/2. And then 5 over 2 plus 1 is going to be 7/2. So these are my new y values. My new x values, I simply will just add 2 to my x's. So my new x's, my old x was -1 plus 2, because if you look up here, it says -2, we got to do the opposite. So that's going to give me +1. And then 0 plus 2 is 2. And then 1 plus 2 is 3. So my new coordinates are 1 and 11/10, 2 and 3/2, and then 3 with 7/2. And I should have did the x's first. I'm sorry, guys. But we still got it done. So 1 and 11/10, it's a little higher than 1. So that's about here. 2 and 1.5. So that's a little higher than the previous dot. And then 3 and 3.5. So that's here. My new asymptote is at +1 because k was +1. So this is the new asymptote. Y equals 1. And my new graph cannot touch it, but it can get close. So this is a growth function because b is greater than 1. The domain is all real numbers. The range is, the range is y is greater than 1. In other words, all y values that are larger than 1. That's an easy way to write the range. There are others, but this is easier. Please try and do this one on your own. Now we're going to talk about logarithms and logarithmic functions. So we can go from exponential form to logarithmic form very easily by remembering that you have your base to your power is equal to a number. Well, it'll be the same thing as log with the same base number of that number equal to the power. And all logs have a base. If a base is not written, it is understood to be 10. I know usually things that aren't written are understood to be 1, but not with logarithms, okay? So every log has to have a base, and if it's not written, you're telling me that the base is 10. So on number 3, we're going to convert these into logarithmic form. So I would establish who B, P, and N are. So again, P is your power, your number is 49, and 7 is your base. So my logarithm will have a base 7, and then N is 49, and it's equal to 2. So you do the next one on your own. In a similar manner, I can go from logarithmic form to exponential form. You start at the base, go to the power, and then loop around to get your answer. So my base, my power equals my answer. And you can do the same thing on your own for the next one. To solve for y, the first thing we're going to do is apply a base of 16 to both sides, which means the log 16(4) becomes a exponent and y becomes an exponent. When you do an exponential expression that has the same base number as the log, what happens is they cancel each other out. So this base 16 and this log base 16 disappear, which would leave me with 4 on the left. However, on the right hand side, I still have 16 to the power of y. Okay? That's not the way I wanted to do this with y'all. So sorry. But anywho, but oh yeah, I'm sorry. So we gotta ask ourselves, 16 to what power is 4? Well, we want to get the same base on both sides, like we did last class. So we know that we can change 16 to a base of 4, and it's 4 squared, right? But this y is still here. So now it looks like an exponential equation that the bases are the same. The power of this 4 on the left is 1. So that means 4 to the power of 1 is equal to 4 to the power of 2 times y, which is 2y. Which means that now that the bases are the same, I can make them disappear and the powers fall down. So y is equal, 1 is equal to 2 times y. Divide both sides by 2, so you would get 1 over 2 is equal to y. So what we learned last class and is important to this lesson as well. We're now going to talk about logarithmic functions. Again, the reason we can go from exponential to logarithmic and logarithmic to exponential is because they are inverses of each other. And so that means that the graphs are also inverses of each other. So on the exponential parent, we had negative 1, 1 over b, 0, 1, and 1b. So that means on the logarithmic graph, we're expecting to see the switch because inverse means to switch. So we're going to see 1 over b, negative 1, 1, 0, and b, 1. And then on the exponential, it had horizontal asymptotes. For logarithmic, it's going to have a vertical asymptote. So on the parent, the vertical asymptote is the y-axis. So y equal, x equals 0 is the parent right here. And anytime you shift the graph left or right, remember that the asymptote moves with the graph. And left or right shifts are always affected by h. Up and down shifts are affected by k. And then a, again, will vertically stretch or shrink. It could also reflect across the x-axis. So let's graph together y equals 3 log base 1/2 x minus 1 and state its domain and range. The first thing we're going to do is graph the parent. The parent would be log base 1/2 again, you're going to have 1 over 1 half. So when I have 1 over 1 half, it's the same thing as 2. If you don't believe me, pick up a calculator. So it's 1 over 1b, I'm sorry, 1 over b, comma, negative 1, 1, 0, and then b, which is 1 half, and 1. Those are the basic points for the parent function. So let's graph those. So 1, 0 is here. 2, negative 1 is here. And 1 half 1 is up here. So this would be the parent for this particular base. Again, x equals 0 is the vertical asymptote. Now, on this one, I'm going to demonstrate finding the new x value first. So according to the parentheses, it says take your x values and subtract 1, but parentheses lie, so we're going to take our x values and add 1. So that's 2 plus 1, which is 3. That's 1 plus 1, which is 2. And 1 half plus 1, which is 3 halves. So these are our new x values. 3, 2, and 3 halves. And then I'm now going to find our new y values. Our y values say take 3 times each y, because this 3 out in front means to multiply. So that's 3 times negative 1, which is negative 3. 3 times 0, which is still 0. And 3 times 1, which is 3. So my new points are going to be 3 and negative 3, 2 and 0, 3 halves, and 3. So let's graph these. So 3, negative 3, 2, 0, and 1 and a half, comma 3. So as you can see, each point has so much space in between them. That's what happens when you have that 3. That's a vertical stretch. Oh, and then we have a new vertical asymptote because we shifted to the right 1 time. So did the asymptote. It is now x equals 1. So here's our new logarithmic. Not exactly so straight right there, but I'm sorry, my pen is not cooperating today. So the domain for this one is x is greater than 1, because as you can see, anything less than 1, there's no graph over there. And then our range is all real numbers. Even though it looks like it's kind of leveling off on the bottom, it's not. It's going to continually move downwards, just at a slow, steady pace. For number 7, it wants us to find the inverse and then graph. So we've done a lot of examples of finding inverse. The methods are still the same. First, change f of x to y is necessary. It's not necessary for this one. Second, replace or switch x and y. So x becomes y and y becomes x. Done. Now we get y by itself. To get y by itself, I need to change it from exponential form to logarithmic form. So I need log base 10 x equals power, so y minus 1. So again, I rewrote it in logarithmic form. I have the same base, my number comes over here, and then my power is on the other side. Now, the last step to do to get y by itself is to add 1 to both sides. So I would have log base 10 of x, skip some space, minus 1 equals y. And this is your inverse function. Do not put x minus 1 in parentheses, please. Don't do that. So now that you know your base and how it's shifting, I want you to graph it by itself. I've helped you out far enough. And then state its domain and range.